Good morning and welcome back to Dr. Logic Awkwardly Does Logic. In this video, we're going to do another correspondence proof, and then we'll do one more after that, because hopefully between the three proofs, you'll have a chance to see what are the general methods that work, whatever kind of frame property and modal axiom you're looking at, and which moves I do are kind of specific to the individual cases that I'm looking at. So before I tell you which one we're going to do, let me bring up my whiteboard so that we can fit everything out. This is going to be the correspondence between seriality, which is just another way of saying that there are no dead ends, or saying that for every x, there is a y such that x sees y. And this is going to correspond to the modal axiom that necessary p implies possibly p. So you'll remember, in order to do correspondence, we have to show both that if the frame is serial, then the formula is valid on the frame. And if the frame is not serial, then the formula can be falsified on the frame. So we'll start with number one. That one is always kind of the easy direction. If we have a serial frame, so assume that we have a serial frame, but that in fact the formula is not valid on the frame. This means that there is a model M on the frame F and a world W in that model, such that the formula necessary P implies possibly P is false at world W. So we can model it this way. Here we have necessary P is true, but possibly P is false, because this is the conditions for making a conditional false. Now, because of our assumption that F is serial, we know that W can see something. Namely, let's draw it over here, call it W prime. Let's put that up there. That's no, there we go. Okay, it can see something, namely W prime. Now, because we've got necessary P true at W and W sees W prime, we know that P is going to be true here as well. But if P is true at W prime, it follows that P is possible at W. So necessity propagates forward, possibility propagates backwards. So the fact that P is true here and W can see W prime means that possibly P has to be true at W. But this is a contradiction with our assumption that possibly P was false. So assuming we have a serial frame, then we try to falsify the axiom necessary P implies possibly P, and we fail. Q, E, D. So let's look now at the second one. So proof of 2. We're going to start off by assuming we have a frame that is not serial. So assume F is not serial, i.e., there is some world X such that for every Y, it's not the case that X sees Y. What does this mean? i.e., X is a dead end. Now, if you remember from our previous corollary that we proved a couple of videos ago, every time that you have a dead end, every formula is necessary there. So by earlier corollary, we know, and this is independent of what the model says. So we don't even have to look at particular valuations, but we know that at, so this world X, necessary P is true. We also know that at this world, necessary not P is true, because every formula is true at a dead end. But then by the definition of truth, we have that at X, not possibly P is true, because we've just swapped the negation and the modal operator and changed the modal operator. So if not P is necessary, then P is not possible. But then we have that at X, necessary P implies possibly P is not true, because we have true antecedent and the negation of the consequent is true. That means the consequent itself is false. So what we know here is that every model on this non-serial frame makes necessary P implies possibly P false at the dead end world. Normally, sorry, not the dead world, the dead end world. Normally, what we need to do is we need to construct a model that will work whatever the frame looks like. In this case, the model is whatever module you pick. The truth value, the truth value assignment doesn't matter in this particular case. So what we have shown here is that if the frame is not serial, then whatever model we end up with, the axiom necessary P implies possibly P will be false at least one world, namely every single dead end world in that frame. So this is slightly different from the previous one that we saw. And there is one more that we will look at, the correspondence of a particular formula with the frame property of being Euclidean. And hopefully between these three examples, you'll be able to go off and start proving correspondence results of your own. So take care, and I hope to see you again soon. Cheers.